So this is video number 2 on minimum spanning tree. This is another famous method out there that is used called the kruskal algorithm. So this algorithm is one of the many methods that are used, but whichever method that you're confident with, then basically you have the same end game. But I feel this one is also a very good and manageable method. So let's have a quick example to actually understand. But remember, in minimum spanning tree, your target is that you should not form any cycles. What do they mean? Let's say you have nodes that are connected in this manner. Let's just have this example. This connection right here, let's say this is A, this is B, and this is C. If we find that we have a connected edge here, a connected edge here, and another connected edge there, we have made the cycle from A, B, C. And that's what they call a cycle, meaning everything is connected. So we're trying to avoid such when we're dealing with minimum spanning tree. We don't want cycles. If anything, the best way A to B to C should be connected is just like this. This is showing us that there's what? There's no cycle that has been created. It's just a connection, and you have achieved the connection of all the nodes or all the vertices, and that's the target of minimum spanning tree. All vertices must be connected. Must be connected. So just ensure all these are done as you are handling the minimum spanning tree calculations. So let's have an example. So let's say we have this one there. This will be called node 2. We can have this as our 4. This will be 3. This will be 7, 5, and 6. So you have that. Let's just have that as our example. Then let's put in some weights, so the amounts that are on each arc. So they are 30, we have a 20 there, 35, 27, 28, 18 here. I think we've labeled everything almost. We can get started. So how does the kruskal algorithm work? Well, the way it is that you have to pick a starting point. So I would say let's just start from 1. I think that's a more logical place to start from. So as you start from 1, consider all the edges that 1 is connected to. If you've noticed, 1 is connected to point 2, point 4, and point 3. So of those 3 connections, you're supposed to be choosing the minimum weights throughout. That's the catch for minimum spanning tree using this method as well, kruskal algorithm. So of those 3 connected edges, which one has got the minimum or the least weight? It's the one with 20. Hence, you even mark it. I'm even changing the color so that you're following through. So I've put orange there. I've marked that one. We move. So you've connected. 2 is part of the sequence now. Then after 2 is connected, remember there are plenty more edges that are not connected in this network. Again, re-examine. So okay, since 2 is now a new edge, you now look at, okay, 2 can also go to 5, 2 can go to 4, but you're also not forgetting that 1 is part and parcel of this network or the minimum spanning tree you're making. So even 1, consider the edges that also 1 can be connected to still. It's not like once you just consider 1, then that's all. You won't be looking back to it. No, minimum spanning tree is the more vertices you're adding, the more places you'll be looking, because there are so many connectivities that will be available. I hope this is making sense. So yeah, like at 1 there, you check, okay, at that, and then when you observe that with these remaining vertices, I think the smallest is 11, which is a connection of 2 to 4. So you pick it as well, and that is selected. So you've now included how many? Already we have got 1, 2, we have 4. So more vertices are being connected. Remember, we have not finished the entire minimum spanning tree, because it's supposed to connect all these nodes, all of them, or vertices. So, well, as we said, the more nodes you add, the more places to look at, or the more connections to look at. So there's a 2 to 5, there's a 4 to 7, there's a 4 to 3, There's a 1 to 4, 1 to 3. So look at all those. Which one is the minimum among these that are left? Well, you will testify to the fact that the smallest one among these connections is 19. Yeah, and you pick 19, 4 to 7 actually, that route. So 7 has joined as well, and then you're keeping track of it. Next, now that 7 is there, okay, now you can look at more possible routes. So, okay, there's a 4 to 3, there's a 1 to 3, there's 1 to 4. But do you know why 1 to 4 will not even be considered, despite it being an unconnected edge? The fact that if I put in a mark here on 1 to 4, just look at the screen. I'm going to use another color so that you're following what I'm trying to show you. If I put in a mark here between 1 to 4, we have actually formed a cycle. Why? If you've seen, if I move from 1 to 2 to 4, they've actually made a cycle. You follow those markings, and we don't aim to form a cycle in minimum spanning tree. So 1 to 4 is out. So even as you're selecting points, take note of those that can form a cycle and ignore them as you're looking for possible routes to come and pick. So even that one goes. So just a minute, I just have to retain what I've just erased. Yeah, so let's get back to what we're doing now. So that route is gone. So we now have basically 4 to 3 to look at, or a possible even 1 to 3, or 1 to 3. Yeah, 1 to 3 is still available for us. Yeah, and we still have a 2 to 5 up there. So which one is the minimum among these routes left? You'll find that it's 22, but 22 is appearing on both the edge of 5 to 7 and 4 to 3. What do? Both are possible edges. From Kruskal's algorithm, you just go ahead and mark them both, just like that. As long as there is no what cycle being formed, they can be part and parcel. Yeah, so you mark both. Then what are you left with? Have you connected all the nodes? No. Node 6 is left basically from all this. Yeah, 6 has not been connected. But how are we going to connect it? Let's re-examine all the routes. Well, we have 3 to 6, which is 28. We have 6 to 7, which is 18. And yeah, basically that's all. Because all other nodes, if you can see at this point, they'll just be forming cycles. So the last possible connection to make 6 part and parcel is 6 to 7. And you're done. So this forms our minimum spanning tree, and what happens is you can actually redraw this and see how the tree has been formed. This is how it's actually looking. When you start removing these unnecessary ones, look at how the tree is actually looking. So can we say we have connected all the nodes in the network? Well, of course we have. So that's the catch behind minimum spanning tree. And then after you're done, it will just be a matter of summing up these total weights on all these edges that you have picked. So it will be 20 plus 11. Sorry for that. So it will be 20 plus 11 plus 22 plus 19 plus 18 plus 22. Just ensure you've picked all the numbers. Then you add up. Just a minute. Just getting my calculator as well. So you get your 20 plus 11 plus 22 plus 19 plus 18 plus 22. 112 is the answer I'm getting. So you just be sure that you've picked everything correctly, and that should be your answer.